Okay, let's be honest. We've been so focused on SpaceX and NASA that we didn't realize a giant has been quietly building a highway to the moon. We're no longer talking about replicas or copies of Western technology. We're talking about scientific progress that is making the Pentagon increasingly uneasy. Just recently, China successfully carried out a crucial test for its newest rocket, the Long March 10. And if these tests continue to go smoothly, space dominance could shift faster than we ever expected. This is the new reality of China's scientific advancement. So let's break it down. What exactly makes the Long March 10 such a hot topic among aerospace experts worldwide? Why has this name been appearing so frequently in recent technology intelligence reports? Simply put, Long March 10 is not just another rocket. It is a 90-meter tall metal beast born from one of humanity's most ambitious goals. The rocket has one mission: to land taikonauts on the moon before the year 2030 arrives. Recently, China completed a critical static test of its core propulsion system. The result? By most accounts, it exceeded expectations. Flawless. We're talking about extraordinary thrust engineered, at least in theory, to rival or even surpass NASA's Space Launch System and Elon Musk's Starship, both of which have long dominated the headlines. But what truly has Western analysts puzzled is not just its massive size, it's the efficiency. China has developed a 3-stage configuration capable of delivering up to 27 metric tons directly into trans-lunar orbit. Imagine that 27 tons. That's the equivalent of sending several fully loaded school buses toward the moon. And unlike some other national programs, China appears to be moving with calculated precision, minimizing bureaucratic delays and political budget disputes that often slow large-scale aerospace projects elsewhere. Long March 10 is physical proof that China has moved beyond merely trying, it is now executing at scale. This machine could transform the moon from a distant celestial object into a new frontier of economic and scientific expansion. This is the beast poised to open the gates to the future. Now, let's move to the most sacred part of any rocket, its engine. Because honestly, building a massive rocket body is challenging, but building an engine that doesn't explode while carrying thousands of tons of fuel, that is high-level scientific wizardry. The true secret behind Long March 10 lies in the YF-100K engine, a liquid oxygen and kerosene (LOX) RP1 engine that operates using a staged combustion cycle. For those unfamiliar, this technology is often considered the holy grail of rocket engineering. Why? Because it extracts nearly every drop of energy from the fuel with maximum efficiency. China is no longer relying on older, less efficient engine designs. They have transitioned to technology that is cleaner, more powerful, and most importantly, more stable. The recent test was not merely about ignition. It was proof that they have mastered the metallurgical precision required to withstand extreme pressures and temperatures capable of melting ordinary steel in an instant. Inside the combustion chamber, a firestorm rages at pressures thousands of times greater than Earth's atmosphere. And China has made it operate with millimeter-level precision. The success of this engine sends a strong message to skeptics who once believed China would need decades to match the efficiency of American or Russian engines. With the YF-100K, China has formally reduced its dependence on foreign design philosophies and established a new benchmark in materials science efficiency. This leap is not only about raw power, it's about intelligent digital control systems. Advanced algorithms now allow real-time thrust adjustments during flight. This is the foundation that makes Long March 10 not just powerful but smart. It is the heart that will drive China's ambitions all the way to the lunar South Pole. There was once a very popular narrative in the West, a dismissive one. Many space analysts mocked China's space program, calling it merely a photocopy of outdated Soviet technology, or simply a follower retracing steps NASA had already taken decades ago. But if we still cling to that mindset in 2026, it's clear we are making a serious mistake. That narrative is dead. China is no longer following. It is now setting new standards that are forcing the rest of the world to accelerate. Look at the current reality. As the International Space Station, ISS, ages and approaches retirement, China already operates Tiangong, a fully functional, modern space station managed independently. While other nations debate budgets, China has successfully landed robotic explorers on the far side of the moon, a region never previously visited by any human or machine from another country. Long March 10 is tangible proof that China no longer needs an external instruction manual to achieve radical scientific progress. This competition is no longer about who arrives first, but about who remains consistent. While the United States often cycles through shifting political priorities every few years, China operates under long-term strategic planning, frequently described as a 3-0-year plan. The speed of its innovation, supported by the world's largest manufacturing supply chain, enables it to produce rocket components at a pace comparable to consumer electronics production. This is a scientific rivalry not seen since the Cold War. The world must now confront a new reality. Leadership in space science is no longer the exclusive domain of one or two nations. With the successful testing of Long March 10, China has formally challenged the status quo. They do not simply want a seat at the same table as NASA, they intend to build a new table on the surface of the moon. And the question is no longer whether they are capable, but whether the world is ready for scientific leadership emerging from the East. Let's talk about a very specific number, 2030. For many people, it may sound like a distant future. But for the China National Space Administration, CNSA, it is a deadline that is rapidly approaching. Long March 10 was not built merely to orbit Earth or launch communication satellites. No, this rocket has one highly prestigious mission: to place the first Asian astronauts on the surface of the moon. China does not simply want to visit. It plans to establish a permanent research base at the moon's south pole, a region rich in water ice that can be converted into fuel and oxygen. The method they have chosen is both intelligent and efficient. Instead of building a single skyscraper-sized mega rocket at enormous cost, they are pursuing a dual launch strategy. One Long March 10 will carry the lunar lander, while another will transport the astronaut crew. The two spacecraft will rendezvous and dock in lunar orbit before descending to the surface. This strategy demonstrates tactical maturity in managing both risk and cost, a pragmatic yet highly ambitious approach. But how are they moving so quickly? If you observe closely, the pace of China's aerospace industry today challenges traditional assumptions. While many space projects in other parts of the world become stalled in years of budget debates or repeated technical delays, China appears to be accelerating. They are moving from one testing phase to the next within months, not years. The secret behind this speed lies in deep integration between government agencies, universities, and the manufacturing sector. China has built an ecosystem where feedback from failures is processed almost instantly. They are not afraid of small test failures if it ensures success in larger milestones. Backed by massive investment in STEM education, they have cultivated a large generation of highly skilled young engineers, working relentlessly to refine every bolt and every line of algorithm in Long March 10. This speed of innovation is driven by one force: unwavering national ambition. For China, space technology represents the highest symbol of scientific power. Their manufacturing facilities now use some of the most advanced robotic systems on the planet, enabling rocket components to be assembled with extraordinary precision and in significantly less time than traditional global industry standards. That is why Long March 10 was able to pass its recent engine tests so smoothly. They are not rushing, they are simply operating at a level of efficiency the world has rarely seen before. So now the question is, what are the real benefits of all this rocket technology for those of us here on Earth? The success of Long March 10 isn't just about the spectacle of flying into space. It's about opening the door to extraordinary new resources. Imagine if we could harness clean energy directly from the moon and bring it back to Earth. Whoever has the most efficient vehicle to get there will lead economic progress in the future. So this rocket isn't just a machine, it's a bridge toward a better future for humanity. Of course, this journey won't always be smooth. There are still major challenges to solve, from orbital safety issues to preventing the growing accumulation of space debris. We all hope that advanced technology like Long March 10 will ultimately be used to foster international cooperation rather than unhealthy competition. After all, space is far too vast to be claimed or enjoyed by just one party. Now, what do you think? What other breakthrough technologies might surprise us in the future? Share your thoughts in the comments, I'd really love to discuss them with you. And don't forget to click subscribe and turn on notifications on the Sacred Tech Insights channel so you won't miss the latest updates on the most exciting technologies. Thank you for watching, and see you in the next video.